Aim for the stars and be ready to be enthralled. 7 fresh photos released by the James Webb Space Telescope lately entice us to explore the unknown regions of the cosmos. These images, which range from complex nebulae to far-off galaxies, prompt us to wonder about worlds beyond our own. In addition to being artistic masterpieces, each image also solves a mystery that fascinates scientists and night sky watchers worldwide. Are you prepared to take a cosmic voyage? Now, just a look away are the wonders of space, and the journey is sure to be nothing short of captivating. First on the list is the Ring Nebula, a celestial wonder located in the Lyra constellation. A fascinating depiction of the Ring Nebula is painted on the enormous canvas of space. This planetary nebula, also known as M57 or NGC 6720, is situated in the constellation Lyra and provides a wealth of information on the life and death of the cosmos. You may wonder what precisely is a planetary nebula. It has nothing to do with planets, despite its name. It's a cloud of gas and dust that forms when a star that is dying, much like our Sun, expels its outer layers. These outer layers are expelled from a star when its fuel runs out, leaving behind a core that keeps the surrounding ejected material heated. This produces a striking structure that we identify as a nebula. Astronomically speaking, the Ring Nebula is rather close to Earth, 2,300 light-years away. Traveling at the speed of light would need 2,300 years to reach your destination. It looks like a ring because of its dimensions, which are 2.17 arc minutes, a unit of measurement for celestial objects. We now have an amazing image of the Ring Nebula with previously unseen features thanks to the James Webb Space Telescope. The sharp picture obtained by the telescope's near-infrared sensor enables us to investigate the nebula's secret depths. What distinguishing characteristics are we able to identify in this amazing picture? Initially, we see the inner ring's filament structure, which resembles interwoven threads. It's a detailed pattern that illustrates the complicated mechanisms involved in stars' skin-shedding processes. The nebula is filled with around 20,000 dense molecular hydrogen-filled globules. This kind of hydrogen is not present in a molecule of water. Rather, it's a plentiful and unprocessed version of the element that's often found in space. In contrast, there are indications of very hot gas in the nebula's interior. A thin ring of carbon-based molecules known as polycyclic aromatic hydrocarbons, or PAHs, is present in the nebula's primary shell. Why are PAHs considered so unique? These are sophisticated chemicals that can also be found in grilled food and automobile exhaust on Earth. A set of around 10 concentric arcs is located just outside the center ring. These are thought to be the product of the central star's interaction with a low-mass companion star that orbits at a distance similar to that of Earth and Pluto. Imagine the traces left by the interaction of 2 dancing partners in space. Astronomers are doing a kind of cosmic detective work in trying to solve the riddles surrounding the Ring Nebula. To find out more about the star that created the nebula, scientists examine it. It's like cosmic archaeology, using the current structure of the nebula to provide historical hints. In addition to providing a stunning visual display, the study of the Ring Nebula provides profound insights into the functioning of the cosmos. Isn't it amazing how a star's demise can produce such an intricate and meaningful work of cosmic art? Brilliant and packed core. However, the placement of these photographs complements the current site data rather well. The closely spaced stars of M92 are highlighted in the picture taken by Webb's NIRCom, which spans a field of view around 9 light-years wide. Observing a globular cluster like as M92 is similar to discovering a wealth of information on the behavior, evolution, and interactions of stars. With a planet's night sky glistening with starry splendor in the heart of M92, what more marvels may be concealed inside this compact cluster? With so many old stars in such close proximity, what tales about our cosmos might they impart? The discovery of M92 by the James Webb Space Telescope is but the beginning. It is a taste of the many mysteries that lie beyond our limited understanding in the enormous universe. A moving star cluster in nebulous light. There are many amazing vistas in the cosmos, and NGC 346 is only one of them. Located 200,000 light-years from Earth, NGC 346 is a vibrant, active area brimming with life, nestled under the constellation Tucana. This star cluster was made visible here by NASA's James Webb Space Telescope's sensitive near-infrared sensor. Nyarkom is located in a nebula inside the tiny Magellanic Cloud, a nearby dwarf galaxy to our own Milky Way. With a field of view of 240 light-years, or around 3.9 arc-minutes, the picture has an amazing scope. What, however, is so remarkable about NGC 346? What are these vivid hues that we're observing? Let's investigate more closely. The picture demonstrates the existence of more building pieces for planets and stars than we had first thought. It is made up of dusty, hydrogen-rich clouds, which are the building blocks of celestial bodies. Two different forms of hydrogen gas are reflected in the interesting colors of these clouds. Energized hydrogen is the pink gas shown in the picture. Think of it as an exuberant, sweltering dance as the temperature soars to around 10,000 degrees Celsius, around 18,000 degrees Fahrenheit, or higher. It's a bright, active region of the nebula. The ridges that are seen all around NGC 346 depict a narrative of change. These ridges are like the footprints of the newborn stars, proof of their existence and activity, formed when the bright light of the young stars bursts through the thick clouds. The region's star erosion has sculpted and molded the many pillars of incandescent plasma, creating a sight akin to sculptures. As they cut through the thick clouds of gas and dust, they display the impact of the star's light and wind. NGC 346 provides a window into the formation and development of stars with its cluster and nebulosity. It's a thriving, dynamic area that can teach us a lot about how the cosmos functions. Is a fascinating and intricate cosmic phenomena that transitions from the energizing dance of hot hydrogen to the tranquil waltz of cool molecular hydrogen. What further secrets may this cluster hold? Could the icy areas be the site of planet formation? What new information on the development of stars and galaxies will come from future observations? There is still plenty to be discovered about NGC 346, and it still arouses astonishment and intrigue when we gaze further into it. The North Ecliptic Pole Time domain is shown in Image 4. For an instant, imagine a little portion of the sky and your eyes being drawn to it. Within that tiny window, you will be able to see a vast array of celestial marvels. This is exactly what the PEARLS project's North Ecliptic Pole Time Domain Field, NEP, has shown. Tucked away in the Draco constellation this deep, survey provides an amazing view into the depths of the cosmos, making seemingly inaccessible objects appear quite close. Surprisingly, this picture only covers 2% of the night sky, which is occupied by the full moon. However, in this little area, Hubble's Advanced Survey Camera, ACS, and Wide Field Camera 3, WFC3, together with Webb's Near-Infrared Camera, NIRCam, have photographed an enormous cosmic tapestry. However, what does all of this signify, and why is such a little area of space important to us? Along with ACS and WFC3, which add 3 additional filters to the mix, NIRCam offers a view spanning the 0.255 micron wavelength range in 8 separate filters. The whole PEARLS field will be almost 4 times bigger than what is seen in this picture. Astonishingly detailed images of thousands of galaxies, each consisting of a huge assembly of stars, gas, and dust, are shown, many of them for the first time. While some of these galaxies are quite close to us, others are incredibly far away. It takes their light about 13.5 billion years to reach Earth. Can you comprehend the immense distance that light has traveled over in terms of both time and space? This picture is a composite of many exposures rather than a single photo. Some stars seem to have additional lines emanating from them if you look attentively. We call these spikes diffraction, a remarkable phenomena brought about by the way light bends around the structures of the telescope. They provide a scientific picture, a dash of creative flair, akin to the equipment's artistic trademarks. What is the universe's meaning revealed by the time domain field of the north ecliptic pole? What mysteries lie inside these far-off galaxies? What can they tell us about the early universe and how have they changed throughout time? A glimpse into a cosmos full of wonders waiting to be discovered and comprehended is provided by the NEP and Pearls project. We are reminded, as we explore this little but important area of the sky, that curiosity and discovery have the capacity to bring even the most remote reaches of the cosmos closer. We have only just begun to explore the vastness of the universe. What mysteries are ahead in the Draco constellation? How many stars and galaxies remain to be discovered? We're invited to go on a cosmic exploration adventure by the North Ecliptic Pole Time Domain Field, which is expected to deepen our knowledge of the universe in ways we can only begin to comprehend. Picture 4. The Enigmas of Quasar J0100+2802 and the universe around it. Gazing into the region between the Pisces and Andromeda constellations, one would be presented with an amazing celestial display taken by the James Webb Space Telescope. Quasar SDSS J0100+2802 is located here, a supermassive black hole in active orbit that shines brightly among almost 20,000 galaxies in a region spanning about 6.7 arc-minutes. However, why is this quasar so fascinating, and how can it provide insight into the early stages of the universe? The quasar, which is the center of this picture, is small and pink, with 6 prominent diffraction spikes on top of it. To put it simply, a quasar is a kind of very brilliant astronomical object that is powered by a supermassive black hole located at its core. This specific quasar illuminates the atmosphere between it and the telescope with such intensity that it functions as a cosmic spotlight. Despite being an incredible 12.8 billion light-years away from Earth, the quasar's position enables scientists to investigate the nearby galaxies and the dark gas that is now illuminated by its powerful light. Imagine being able to comprehend the basic structure of the space around the galaxies in addition to being able to view them. What does this reveal about the early universe? The ETH Zurich research team, under the direction of Simon Lilly, centered their observations on Quasar J0100+2802. A detailed analysis of 117 galaxies that predated the Big Bang by about 900 million years was conducted. Pay particular attention to the 59 that are directly in front of the quasar. These galaxies existed just before a momentous event known as the end of the reionization epoch. What, however, is reionization? Hot, thick gas engulfed the cosmos after the Big Bang. This gas cooled steadily until it abruptly heated up, ionized once again, and changed from opaque to transparent. Why did this change occur, and what effect it had? The cosmos comprised a complicated patchwork of opaque and transparent, or ionized, gas during the reionization phase. A period of immense change occurred when gas around billion-star galaxies ionized and became transparent. Hot air balloons are comparable to the transparent areas of gas, according to Daiichi Koshino of Nagoya University in Japan, with pea-sized galaxies filling the empty space. Webb demonstrated that at a 2 million light-year radius, roughly the same distance as our Milky Way and Andromeda, galaxies completely ionized the gas. These bubbles expanded and finally fused over the next 100 million years, becoming the cosmos transparent as a whole. How do these discoveries change the way we think about this particular point in the history of the universe? These exciting observations, which provide a greater understanding of the structure and behavior of the early cosmos, were announced by the Eiger team emission line galaxies and intergalactic gas in the period of reionization. Even though Webb's initial picture and associated spectra from its near-infrared camera, NIRCam, were sufficiently precise that conclusive findings could be made without further observations, The team intends to have photos and data from 6 fields focused on several quasars. Could the enigmas surrounding Quasar J0100+2802 provide us with deeper insights into the origins and development of the universe? What else may be gleaned from continuous deep-field studies such as EIGER? These intriguing tidbits of cosmic history promise to continue piquing our interest and expanding our knowledge. The enormous fabric of the cosmos keeps unraveling, one light year at a time, one quasar, one galaxy. The fifth image provides a close-up view of a star-forming miracle while examining a chaotic tarantula. There are many amazing things in the cosmos, but few are as fascinating as the Tarantula Nebula, or 30 Doradus. This tumultuous area of space is found in the Dorado constellation. But what exactly is unique about the Tarantula Nebula, and what can it teach us about the stars themselves? The Tarantula Nebula is an amazing star-forming area located in the massive Magellanic Cloud, an astonishing 161,000 light-years distant from Earth. Imagine enormous clouds of ionized hydrogen gas, giving birth to brilliant, freshly born stars as they swirled, twirled, and interacted with one another. Images from the Webb show these tumultuous clouds of gas and dust, which are both erratic and fascinating. But why do scientists find these clouds so fascinating? And what's really going on within these clouds? It is not just any star-forming area that is the Tarantula Nebula. In our vicinity of the galaxy, it is the brightest. Additionally, the biggest and sexiest celebs that we are aware of reside there. Because of these harsh circumstances, astronomers may study, research, and test their hypotheses on star formation and development in this ideal laboratory. In a sense, the Tarantula Nebula gives astronomers a window into the fundamental processes involved in the formation, development, and evolution of stars. How are these enormous stars formed? What do they have to say about the structure of the cosmos itself? One of the recently made public photos of the Tarantula Nebula is an amalgam of information from 2 distinct observation schemes. The first, aptly titled Scylla, is concerned with investigating the characteristics of dust grains floating in the interstellar medium. These dust grains are unlike your typical dirt particles. They are the fundamental elements that form the shadowy clouds that weave across the picture. However, in what ways do these dust particles interact with starlight in different settings? How do they aid in the process by which stars form? Ulysses is a different observation idea that complements Scylla's objective. Together, they're revealing details about the light-dancing intergalactic dust, as well as participating in the grand cosmic ballet. Discovering the mysteries of dust and stars is not the only thing the Tarantula Nebula image can achieve. Data from an observation program that aims to examine star formation under circumstances like to those in the early cosmos is also included. All in all, research on the Tarantula Nebula might provide hints to scientists about the state of the cosmos just after the Big Bang. How did the cosmos first exist? What impact did it have on the planets, stars, and galaxies that we see today? Astronomers continue to be fascinated with the Tarantula Nebula, and people who see its pictures are filled with amazement and wonder. Its tumultuous clouds, enormous stars, and enigmatic interstellar dust provide a wealth of uncharted territory for exploration. We get closer to comprehending not just the Tarantula Nebula, but the cosmos as a whole with each new picture, observation, and hypothesis tested. In the years ahead, what else may this intriguing part of space reveal? As we work to untangle the intricate web of the Tarantula Nebula, one cosmic thread at a time, only time and further research will tell. The 6th and 7th objects in the Large Magellanic Cloud are NGC 2014 and NGC 2020, which are cosmic clouds located in the Dorado constellation, sometimes referred to as the Swordfish. An amazing duo of nebulae catches the attention and sparks the imagination. NGC 2014 and NGC 2020 are two bright gas clouds that stand out as celestial jewels in the vast fabric of the cosmos. However, what exactly are these nebulae, and why are astronomers drawn to them? NGC 2014 and NGC 2020 are remarkable objects located in the Large Magellanic Cloud, one of the Milky Way's satellite galaxies. These bright clouds are vivid representations of cosmic occurrences rather than just regular clouds. The power of winds from scorching newborn stars has bent and molded the gaseous structure of NGC 2014, giving it the appearance of a complex work of art. Its companion in space, NGC 2020, has comparable properties. However, what can be learned about the stars that shape these formations, and how can these winds produce such amazing shapes? Consider the tremendous heat and energy that recently created stars would radiate. Strong winds from these stars push and pull on the surrounding gases. The wind's power shapes and sculpts the gas into beautiful patterns in this natural dance. These winds combine with the gas to produce a bright light that is visible from Earth. This lighting effect is more than simply visually striking. It offers vital information on the activities taking place within the nebulae. Star-forming areas and cosmic nurseries are terms often used to describe nebulae such as NGC 2014 and NGC 2020. However, what does it imply for a nebula to serve as a star nursery? New stars are formed among these clouds of gas and dust. Nebulae are shaped by the process of star formation, which also produces the elements needed for stars to develop in their dense areas. These nebulae are not only immobile objects, they are dynamic, ever-evolving, and shaped by the stars that they assist in creating. What can we learn about the star's life cycle from these formations, and how do stars develop inside these nebulae? When NGC 2014 and NGC 2020 are seen in the same frame, the sight is mesmerizing. Because of their close proximity, a comparative analysis may be conducted, illuminating the nuances of their interactions with their surroundings. What's it like to fly through these bright gas clouds, one would wonder? What secrets do they conceal, and what do they reveal about the nature of the cosmos as a whole? The Dorado constellations NGC 2014 and NGC 2020 are more than simply breathtaking objects to look at. They stand for an intricate and dynamic region of the universe where the forces of nature are manifested on a massive scale. These nebulae are a fascinating topic for research, from the complex ways that winds from newborn stars create these clouds to the birth of new stars inside them. They serve as a reminder that the cosmos is a dynamic, ever-evolving world of wonder rather than a static location. Investigating these astronomical occurrences leads to a better knowledge of the systems that control the cosmos as well as these specific nebulae. How many more mysteries like NGC 2020 and 2014 are there for us to discover? And what fresh perspectives on the great cosmic dance will they bring? As they say, the sky is just the beginning and not the limit. Picture 7. The Veil Nebula, revealing the secrets of a supernova remnant in the constellation. Known by several names, including Cygnus Loop or NGC 6960, Cygnus, the Veil Nebula, reveals a cosmic tale. What seems at first like a mysterious and broken cloud is really the remnants of a gigantic supernova that burst millions of years ago. However, what is a supernova remnant precisely? And why does the Veil Nebula interest scientists and space enthusiasts alike so much? Once upon a time, a star some 2,100 light-years from Earth came to an end. Unable to resist gravity, the star broke apart and burst into a tremendous explosion. Called a supernova, the Veil Nebula, a beautiful and intricate structure that depicts the demise of a star, is what we now recognize as the remnants of this explosion. It is quite an accomplishment to capture the Veil Nebula in its entirety in a single photograph because of its enormous size. With its sophisticated capabilities, even the James Webb Space Telescope could only examine a tiny portion of it in detail. This constrained perspective might raise a query. If we could view the whole nebula at once, what else would we discover? As a supernova remnant, the Veil Nebula is defined as the remains of a star that has burst into a supernova. But after something as catastrophic as this, what really is left? Shock waves from the explosion cause ripples and intricate patterns throughout space. Beautiful filaments and arcs have formed from the gas and dust that previously made up the star. These substances combine with other components in space to produce what may be seen as a veil of heavenly brilliance. Scientists may learn important things about the birth and demise of stars from the Veil Nebula. They may put together information about the characteristics of the original star, the forces that caused its explosion, and the effects it had on its surroundings by analyzing the supernova remnant. How does a star's explosion form a nebula? And what mysteries does it hold about the cosmos? What mechanisms are at work in this formation that seems to be chaotic? Examining the veil. Strong telescopes are necessary, but studying nebulas also calls for a thorough grasp of astrophysics. Scientists understand what's occurring within the nebula by examining its brightness, colors, and forms. It's not all science, however. Seeing something that intricate and far away requires a specific kind of talent. How does it feel to look at an area that captures a dramatic moment in space, preserved in space and time? The Veil Nebula serves as a reminder of the star's life cycle and the cosmic events that mold it. Its complex patterns serve as maps to comprehend basic processes in our cosmos, in addition to being visually beautiful. Even a small portion of observations of the Veil Nebula contribute to our common knowledge of what is out there in space. We are constantly reminded of the dynamic and ever-changing character of space as we investigate and solve its secrets. Is there a way to unlock the mysteries of the cosmos via the Veil Nebula? What new tools or techniques could help us perceive it more clearly? Like most of space itself, the Veil Nebula's investigation is still an exciting voyage with much to be discovered. As we draw to a close our cosmic tour of the James Webb Space Telescope's photos, we can't help but ask, which picture was your favorite? Was it the majesty of a far-off galaxy, or the elaborate dance of a distant nebula? And what do you anticipate we will discover next in the uncharted emptiness of space with this amazing telescope? Let's continue to wonder at the world together by sharing your ideas and dreams in the comments section below. Please remember to like, subscribe, and click the video to see another space adventure. If you like this one, thanks for watching.